Hi everyone, my name is Ryohei Mori, and today I will be presenting our work on leveraging instrumental variables in online advertising auctions to improve click-through rate predictions. This work is a collaborative effort with LY Corporations. These are the tables of contents for the presentation. In online ad auctions, selection bias persists even if the prediction model for user response are unbiased. Furthermore, there's a cold start problem where predictions for ads with fewer displays are significantly less accurate. Our work identifies valid instrumental variables, IVs, in this context and adapts prediction models accordingly. Our experimental results show that IV-based predictions are particularly effective in cold start scenarios, with further improvements observed when considering IV heterogeneity. Before we dive into identify reasonable IVs, it's important to understand the data generation process in online ad auctions. There's a well-known bias. Advertisements that are more likely to win impressions tend to be selected repeatedly in a feedback loop. However, we point out that this selection bias also stems from user response prediction models, especially when there are omitted variables that aren't accounted for in the model. This creates a feedback loop where biased predictions lead to biased selections, which in turn reinforces the bias in future predictions. Advertisers set their bids based on targeting strategies, which can be either manual or automatic. These targeting variables ensure that the IVs meet the necessary condition of the conditional independence, while also accounting for user response heterogeneity. The relevance of these IVs to the displayed probability varies depending on the targeting strategies and the competition within the auctions. By leveraging this, we test the effectiveness of our method, which explicitly incorporates IV heterogeneity into the prediction models. Instead of the traditional two-stage estimation with IVs, we adopt a one-way inference approach using multitask learning. The loss function for our objectives reflects this approach. This loss function is customized to use only the records that made impressions on the user to predict outcomes. To test the concept of incorporating heterogeneity in IVs, we employ a attention network. Similarly, in modern outcomes, we use an attention network to explicitly account for heterogeneity in treatment effects. The architecture of the integrated summary model is shown in this figure. The right half of the figure is the attention network for incorporating heterogeneity in IVs. The left half of the figure is the attention network for explicitly incorporating heterogeneity and treatment effects on outcomes. To validate our approach, we conducted ablation studies, both in simulations and real datasets. In the simulation datasets, we used our confounded display datasets containing 5,000 records for training and independently displayed data with 50,000 records for validation. We evaluated the performance at each quantile of the extent of confoundedness, comparing several baselines such as naive, IVs-based variants, and unbiased IPS. In the real dataset experiments, we trained on a 7 days period dataset with 50,000 records and validated on the following day's data, which contained 2 million records, independently displayed odds. We evaluated the performance across quantiles based on the odds previous display numbers. Our evaluation scores are as displayed. In the simulation results, our method outperformed their baseline approaches, particularly in scenarios with a high degree of confoundedness. The inclusion of IV heterogeneity further improved the predictions, demonstrating the robustness of our approach in handling complex data distributions. Similarly, in the real dataset experiments, our IVs-based models showed superior performance, particularly in cold start situations where traditional models typically struggle. The results suggest that considering IV's heterogeneity can significantly enhance prediction accuracy in these challenging scenarios. To conclude, our study demonstrates that using instrumental variables in online ad auctions can effectively mitigate selection bias, leading to more accurate predictions of user outcomes. The incorporation of IV heterogeneity is particularly beneficial, especially in cold start scenarios. Future work should explore interactions with IV's more advanced techniques, such as graph neural networks, and further evaluate the prediction and auction mechanism and bias loops, considering other forms of exposure or popularity bias.